this is lesson 1.2, and we were starting with a warm-up on domain and range from a graph. This is a really tough one. How did Miranda do on the domain, guys? Any complaints? So she started at the left. She said, well, there's an arrow on the left side, so it's going to go to the left forever, yes? So we have a negative infinity. Then she's headed to the right. She's headed to the right, and she goes over until she gets to -6, because it's counting by twos. Everybody all right? And it stops here, so she put a hard bracket. And then there was a gap in the graph going across until she got here, and she didn't say -6, she said 0. Why is that? Because it's x value. Domain is x values, and we read it left to right. Everybody okay? Then she said open circle meant parenthesis. 0 to 4 had defined values. Open circle at 4 meant parenthesis. Then there was a little gap here going across until she assumed that was 7. I think that's a good assumption. And it has a solid circle. So she did a square bracket to the right because of this arrow going to the right. Any questions? Okay, we're going to go over more of these today. This was just a quick preview. Anybody want to try the range? The range is very tricky on this one. The range is read from where to where, guys? Bottom to top. And it is y values, yes? Y values. Okay, is there any part of the graph down here? But then I hit it at -8. So I have a -8 with a hard bracket because it was a solid circle. Then what? At -6, it has an open circle here. Okay. Anybody going to disagree with that?
Well, yeah, because of the other line, it goes on the -6.
We're looking bottom to top.
It goes on forever and ever.
So as I go up, I started at -8, it had values. Does it still have values here? Does it have values here? Does it have values here? It actually has 2 values, right? One over here, one over here. Values, values, values. Okay, does it run out of values when we get up in here? This gap? This one still has values on this piece, right? It goes up forever. You don't want, I don't care what it's doing a little bit over here or over here. I just want to know, is there a value anywhere that has a y? And it does. Because of this arrow, this answer is just, okay? Because it goes up for, that's a very tricky one. We're going to keep going, and we're going to do some more that are much easier. But that was a quick overview of domain and range, because I think you've done that before, yes? Okay, so one more time, today's learning targets. We're going to talk about domain and range from a graph. We're going to estimate x and y intercepts from a graph, and then we're going to solve for those algebraically. The x-intercepts are also called the zeros. We've used that terminology before. And down here it says they're also called the roots of an equation. When you actually put in a 0 and solve for the x values, they're called the roots. So x-intercepts, zeros, and roots are all just 3 fancy words for the same thing. All right. We're going to find the y-intercepts. It says, remember, the y-intercept is when you put x equal to 0, yes? We've talked about all of this before. All right, this example is kind of hard to see. I hope you have this on your worksheet in front of you. All right, first it wants domain and range. It says use the graph to find the domain and range. What do you think? Domain? I'm kind of extending those in a funky way, but you get that it gets wider and wider. So all real numbers left to right. Is it all real numbers for the range? If we start at the bottom, there was arrows going down, but it maxes out at this point up here. They gave us this point. Which value do I need for the range? I need the y values. So the y's go from negative infinity to that value right there. Everybody okay? Where we got that one? All right. Now, help me estimate quickly, and then we'll find them algebraically. The intercepts. Where's it crossing the y? Can you tell? Somewhere in here. 4? 4.5? 4? Okay. Somewhere in there. It says to find it algebraically. Now, the equation is over here. How do we find the y-intercept algebraically? It is the constant because it is the value when we put in a 0 for x, right? So Basma says we can really just ignore all this because the constant is going to be the only thing left after we multiply all these zeros, right? So it was 4.5. So those of you who guessed 4.5 were right on. And the last one is the x-intercepts. What do you think this is over here? -3. And this guy over here? Positive. Maybe it looks like 1.5. Okay. By the way, let me reiterate. When you write, if it asks you for the y-intercept, I would prefer that you wrote when x equals 0, the y-intercept is at 4.5, right? I'm just making things up now. So write it as an ordered pair. Okay, this one, the x-intercept is when you put a 0 in for y. So we write 0 equals -1x squared minus 1.5x plus 4.5. Okay, I'm not going to do this. I'm just going over it really fast because they did it right here. They took out the -1, then they factored, then they said each part equal to 0. They got -3 and 1.5, which we got, right? So that would be -3, 0, and 1.5, 0 would be the x-intercepts. Any questions on that one? Okay. I like to give you one once in a while that's pretty much done so you don't have to write so much. You can just kind of follow along. Now this one I'm going to ask you to write some stuff down. We're supposed to find the domain, range, x and y intercepts again, or the y-intercept in the zeros. They changed the vocabulary on us. What do you think domain? Left to right? We're good with -infinity to infinity. It's going, got arrows on both ends. What about the range? It is not going to have asymptotes. That's a good question because it's a little bit hard to tell. It kind of looks like it might be flattening out. The other thing you could do, we're going to talk about the equation here in a minute. Does anybody know anything about a cube root? Sorry, I wrote that really crooked. Can you take the cube root of a negative number? Yes. Take the cube root of -8, you get -2, right? We talked about this the other day. That's why it goes left to right. But when you take a cube root, you can get out both a negative and a positive number, right? So therefore, it is going to go up and down as well. Can be any value up and down. The asymptotes occur when we have x's in the denominators, okay? And we have a couple examples of that today. All right. We need to go with the y-intercept. Where does it look like it's crossing the y-axis at? Be careful because I don't know. What are they counting by? 2's down that way? -2, -4, -6, -8. Everybody okay? So we think 0, -8 is 1. It does say we should do it algebraically. If I put a 0 into this function, if I put a 0 in for the x, not the y, I will have 4 cubed roots of 0 minus 1 minus 4. Okay, this is -1. 4 times the cubed root of -1. Anybody? Cubed root of -1 is -1 times 4 would be -4 minus 4 would be -8. So the picture was not misleading at all. All right. Other thing we're supposed to find is the x-intercept. What do you think right there? or the 0, they called it, find the 0. The 0 would be at 2, 0, we're thinking. Okay, how do we find that again algebraically? For the y. Okay, now I need some help because I want you to tell me how to do this. Oh, my algebra gurus. Add 4 first. Divide both sides by 4. We get 1 equals the cubed root of x minus 1. Then what? What is 1 cubed and this side? 1 cubed is 1. This side cubed is just x minus 1. So it looked like a disaster, but we were able to just think about undoing and working backwards, yes? And we did find that 2 was the 0. All right, I just wanted to have you talk me through one that looked really messy because you think sometimes you see those and you, I don't know how to do that, but you really do. Just do your algebra backwards. All right, quick technology tip. This is an idea that falls later in this chapter, I believe. When I look at that equation and type it in my calculator, I should have an idea of a shape. Do you remember these rules? X squared opens up like this if it doesn't have a negative in front of it, right? X to the 4th, x to the 6th, x to the 8th, all do the same thing, except in between sometimes there can be some squiggles, okay? We generally think of an x to the 4th like a W, unless it has a negative out front, okay? If you had typed this in with a standard, did a zoom 6, you would get this graph. There needs to be a connection between what you type in and what you see on the graph, yes? This looks like a line. So you need to think to yourself, I'm not seeing the whole picture here. Okay, self, I need to set a new window, okay? So they changed the window and eventually found this, and that is a very nice graph of this. What I'm trying to get you to do is understand when you type it into the calculator, it may not show you all the zeros and all the graph for the domain and range and all that kind of stuff, okay? You got to think about what you're putting in. All right, we're going to do an absolute value graph real quick. They want us to, again, look at the function and estimate, and then type it in and prove it algebraically. I'm going to tell you right now, there is an issue with one of these. We're not going to get the right answer until we put it in algebraically. Okay, how would I look for where this is? Because that's not a 0 or an intercept. What does that mean to do? Yes, when x is negative 2.5, I'm right over here somewhere. What is the corresponding y value? What do you think? Does it seem like about 12? You get what I'm talking about. When you go to the x equals negative 2.5, go to the graph, we're getting about 12. Okay, it says 2 times the absolute value of, we're supposed to put in a negative 2.5. What's the absolute, first of all, what is negative 2.5 minus 3? Absolute value would make that positive 5.5. Times 2 would be, anybody? 11 plus 1 is? It worked. So that's not the one that was goofy. All right, what do you think f of 1 is? Looks like maybe 5, right? Between here and here. So our guess is 5. So 2 times 1 minus 3 plus 1. Just using this equation here, putting in a 1. What do you think? Can you do that one in your head? 1 minus 3 is negative 2. Absolute value makes it 2 times 2 plus 1. That one was okay? Okay, I kind of gave away the... This one looks like what? I don't know why, but this is not accurate at all. If we put in a 7, it looks on the graph like we're going to get out an 8. But what happens if I put in a... Ooh, not that. What if I put in a 7 where I'm supposed to put in the 7? 2 times 4 plus 1 should be 9, yes? Well, I think they didn't draw this branch right. It doesn't look quite steep enough on that side. All right. I got one better one for you in a few minutes here, though. There's a really messy graph. All right, we're going to do a little game here. We're going to play Call on Someone. Domain of this one. Michaela, can you tell me the domain of the first one? If it had arrows, it would absolutely be. But because it stops here, we want the furthest left it goes to the furthest right. And you got to be a little bit careful. I think they're counting by twos. -2, -4. To +3 over on this side, yes. Hard bracket or soft bracket? When would it be soft, guys? Open circle. Yep. This has a solid circle, so we're going to go with that. All right. Michaela was brave and went first. Omar, what's going on with the range on this one? Bottom to top. Watch the scale. Square bracket? Okay. I'm going to call on somebody else to tell me if he's right. Kirsten, what do you think? She says yes. Anybody disagree? No. All right. Camden, domain on the number 4.
Soft bracket, -infinity to hard bracket 4.
Jacob, is he right or not? Left to right, he is correct. Good job. Aunt Pat, can you tell me the range on this one? Yeah, I think they're just counting by ones going up, guys, right? And it looks like it hits 3. It doesn't have an open circle or anything. So I'm going to put a hard bracket for him. Yes, guys, what do you think? All right. No? I thought it did, but see how this is 2? The X is by 2s, the Y is by 1s. No, it doesn't count. It's numbered weird, but it's, yep. All right. Number 5. I think I won't be mean and pick on somebody. Can anybody volunteer to guess what they think is going on here? Jacob? And can you explain why that would be? There is. And can you tell, guys, from this equation why there is? Remember we talked yesterday, x in the denominator means that can't be 0. The denominator can't be 0, and that would be the quantity 0. Perfect, Jacob. What about the range, guys? Negative infinity to positive infinity? Let me explain a little bit, try to help you understand why. There is an asymptote. It's hard to tell from the graph, but it's undefined here and here. So when we go bottom to top, it's undefined at 0 as well. Because there's no way to make this equal 0, yes? -2 divided by nothing will become 0. If I tried to multiply the x over here, I would get 0x equals -2. That's not true. So there's no value that works. So therefore the range is the same. That one is hard because there is not a clear algebraic solution. It's hard to tell from the graph for sure if there's an asymptote what's going on. All right, I have extras just to pick on someone. Riley, you try domain on this one. Counting by 2s, I think, both ways this time. Yes, nicely done. Larissa, can you do the range for that one? What do you think, guys? Anybody want to help her out?
Do a hard bracket at the beginning of the soft
Going left to right, it looks like we have a hard and a soft because of the circle and the open circle, but remember, we're going bottom to top. And there's a struggle for students, but is there a value at 0? Yes, it's over here. So it doesn't matter that this is open, because if the graph did this and never even came back down, right, it would still be 0 to whatever. So the fact that it has an open circle there doesn't affect the range at all. And so since it had a hard bracket at 0 over or on the -2, this is hard. What about the 4, guys? If it looks like it's hitting it and it doesn't have an open circle there, I'm going to go with it is hitting it, okay? All right, 28 is difficult. Basma, what do you got? Those are open circles. It's really hard to tell from back there, but they are all open, okay? They're all soft, and so is there a value here at 2? +2 to infinity, yep. Everybody okay? That was kind of messy. It's even messier for the range. Anybody want to try it? -infinity to something. There's a big gap in here, right, where there's no values for y. So we got -2, and that's going to be an open circle. It's hard to tell. Okay, how do you write 6 to 6? It is 6. Are there values there? Yeah, there are values. So I'm going to use hard brackets because I know it has open circles on the end, but that has to do with x values, right? Up and down, it includes 6. That was a mess. Okay, we need to talk on the back about symmetry. You talked about lines of symmetry and point symmetry in geometry, whether you remember it or not. If we draw a little heart on our paper, we can draw a line of symmetry down the middle and split it in half, right?
Yeah. Unless I drew a really bad one.
Okay. Point symmetry was when you could flip something upside down and it looked the same. You could rotate it 180. Does that sound familiar? Okay. So this has line symmetry, means you can fold it along a line. The line symmetry we're going to talk about today is respect to the x-axis or with respect to the y-axis. Okay? Now you can fold something along the x-axis and the top will match up to the bottom. That means these two y values are different when you put in the exact same x value. So if you replace y with its opposite, you will get this equivalent equation. Is that a function? If something folds in half over the x-axis, is it a function? Okay, so very important. Things can have x-axis symmetry, but they will not be a function. Y-axis symmetry, on the other hand, is when it folds in half this way. So you fold it vertically and the two sides match up. That means for the same y value, I get the opposite signs on the x values. So I can replace x with its opposite and it will go back to what it was when we started. This is a function, okay? It's going to have a special kind of function name in just 1 second. The third kind of symmetry is point symmetry, we called it in geometry. And it meant we rotated it 180 degrees and it looked the same. Really quickly, using the advantages of technology, if I take a picture of this graph, just to prove it to you, because I know some of us are not visual, and I turn it upside down, does it look identical? You could turn your paper 180 degrees, okay? So this symmetry is no longer called point symmetry when we do it on the coordinate plane. It's called symmetric to the origin. That point is the origin, okay? So you have to be able to flip it upside down with the x and y axes there. You can't say like, I'm moving things. Whew. If you say, well, I have a shape up here, and I flip that upside down, the shape is going to be the same, but instead of crossing up here on the x, it's going to cross down here, and that's not the same, okay? You got to be able to spin your paper around the origin. All right, the rule for this is that you will exchange the x and the y with their opposite, and you will still be on the graph in equivalent. It'll still be the same values when you check this out. All right. So the ones where we had symmetry with the y-axis have a special name. They're called even functions. The ones that are symmetric to the origin have a special name. They're called odd functions. Why isn't there a special name for x-axis symmetry? It's not even a function. You guys are geniuses. All right. So you have this in your notes. Let's go through these one more time. The even function is which one? Okay, y-axis. So I'm going to write even in here, but I'm going to do a couple other things real quick. I'm going to draw just a really fast example of something that has y-axis symmetry so that I don't get confused. And I'm going to write a couple equations. Y equals x squared minus 6. Y equals negative x to the 4th. Those would be even functions. Just examples for you, okay? Anybody question yet? Okay. An odd function is which one? Origin symmetry. So an odd function is one when you change the x's and the y's both to their opposites and it has no effect. It goes back to the original function. And I'm going to show you what I mean by that in a minute. Sorry, I can't get this box out of here. A quick picture for this. Anybody remember what this function actually is? It could be a cubic. If it went back down and up and down and up and down, it would be a sine curve. I kind of just drew it like a cubic. Y equals x cubed. Oh, what did I forget to write in this box? This is called an odd function. Y equals x cubed. Another odd function is y equals the sine of x, like I started to say. Okay? The one that is not a function at all is an x-axis symmetry, and a real quick graph would be like a sideways parabola, and it doesn't have to go through the origin. Mine just happened to. The kind of things you would see here are x equals y squared, or x equals negative absolute value of y, or some craziness that would make it where two y values would give you the same x value. Anybody lost? Got the notes? We okay? Nobody needs me to wait? All right. This is just a little study tip that says basically there is no function other than f of x equals 0, which is the point at the origin, that has symmetry about x, y, and the origin. All right, I want you to watch this one. I don't think you have this, and I'm fine with you not writing anything down. I just want you to watch an algebraic test. This graph kind of looks like it might have origin symmetry, but we can't tell. It looks like it's the same, but this one looks a little longer to me. The test for origin symmetry, did anybody catch that? It said to replace x with its opposite and y with its opposite, and you should get back to equivalent statement. This is very confusing for students. I want you to just watch this one. If it said y equals x cubed minus 0.5x squared minus 3x, you would replace the y with its opposite, and you would replace each of these x's with its opposite. Think of it like a -1 because it's equivalent. So this is a -1y equals a -1x all to the third. What is a -1 cubed? So this is still -1 and the x is cubed. Be careful. What do you do first here when it has -1x quantity squared? You square it, which makes it positive x squared. And then there was a -0.5, right? Everybody okay? Nobody's lost why that became positive and then negative because of that? And back here, what will this be? Plus 3x. Now, I'm trying to get the y by itself, so I'm going to multiply or divide through by a -1. Does that seem all right? I'm going to multiply just because I'm going to do multiply on the next one. So I have y equals, if I change all these signs, I get x cubed plus 0.5x squared minus 3x. Did we get back to the original equation? We didn't? This is different, right? The 0.5? So this is did not pass our test. It does not have origin symmetry, okay? Not symmetric to the origin. That was a big pain in the neck to test that, but you eventually have to be able to do that. I'm going to talk about some really easy shortcuts as well here, though. Listen to me in a minute. All right, for this question, here's an example. This definitely looks like it has origin symmetry again, okay? Analyze the graph to determine whether we think it's even, odd, or neither. What do we think? It appears to be odd, which is origin symmetry. The test for odd is what? It's the same test we just did. Okay, so the original one is y equals -x cubed plus 2x. If I replace everything with it opposite, I get -y equals negative. Now, this already has a -1 in front of it, yes? And a cube. This is kind of tricky. When I replace the x with a -x, it's the cubed part. And then I replace this x with a -x. That was kind of confusing. All right, this is just -y. What happens first here? -1 to the third power is, but then there was this opposite or -1 on the outside, so it becomes +1. Back here, what happens? 2 times -x is just, okay. Last step? Yeah, multiply or divide by a negative so that I get back to a +1y. What will I get? Anybody? This will become positive. This will become negative, positive. Is that what we started with? So we just algebraically proved that this function is odd, okay? This should have been, I think they wanted us to write symmetric to the what here? Origin. If you're writing on this little blank, I would write first what it changes to, which is you would get out of this -y equals x cubed minus 2x, and then when you change the signs, it would become y equals -x cubed plus 2x, just to show yourself a little work. All right, fire up your calculators. We're supposed to determine if these are even or odd or neither. Somebody type this one in. Really? 2 minutes left and I lose my cursor. Okay. It's not 2 minutes yet, but looks like that. Yes? Vesma says odd. What do you think, guys? A lot of students would say this is odd. If I flip this upside down and put it underneath, does it look identical? This one crosses above the x-axis, this would cross below, yes? Okay, so we're thinking it's not. If you wanted to check, if you put it in negative, you would get this when you multiply, divided through by the negative. You would get this. It's not the same, okay? This is neither. What do you think about 7? Wait, let me go back. Okay. I'll give you the hint in the shortcut in a second. Do this one first. Somebody graph this. Anybody's calculator not working? Anybody get a picture like that? Okay. This looks like it has folds on the y-axis, right? Which isn't what it asked. It would be an even function then. Does it make sense, guys, if I put a negative in and do it to the fourth, it's going to become positive? If I put a negative here and square it, it's going to become positive? This one, the rule was just replace x with a negative x, not the y, just the x. Okay? I want to give you the hint. This had an exponent power that was odd. This actually has 0 x's on it. So the exponent power here would be 0. Is that even or odd? It had a 3 that was odd, a 0 that was even. Therefore, it was neither. This only works for polynomial functions. Meaning if there's a denominator or a square root or something, then you got a whole other mess. Over here, degree 4, power of 2, power of 0. Are those all even powers? Yes. Okay. Turned out to be an even function. Okay. This one is got a denominator, so it could be kind of tricky, but it does have an even exponent. Did anybody graph it? I think it's a volcano. Did you get a volcano? Okay, what kind of symmetry? Looks like y-axis symmetry, right? Which makes it an even function. What is the test for even, guys? Even is y-axis, which means you replace the opposite, which is x, with its opposite. So I have to say this is my original. When I replace the opposite, I get back to the original. Is that true? A negative 1 to the 4th power would be positive. So this is equivalent to 5 over x to the 4th. So there's the algebraic test. All right, what do you think this is just looking at the exponents because it's a polynomial function? It looks like odd. Anybody graph it? I think it's got nice even little bumps there and there, yes? What is the test for odd? Yeah, rotate 180, but what else? Both x and y with the opposites, okay? I'm not going to take time to do that one. Number 10, what do you think? Even would be fold across the y. If you try to fold this across the y, this branch is going to end up over here. Does that on top of itself? This branch is going to end up over here. So that doesn't work. It's not even. Is it odd? Look, I have my technology going for you. Is it still the same? Okay. It says to show that, oh, it doesn't say even or odd. We're not even supposed to be doing even or odd. It's the same thing, but what does it say at the top? Describe the symmetry. So I write what? Origin symmetry. Okay, confirm algebraically. What do we do for origin? Both. So this becomes negative y equals negative 2 over negative x. Well, as soon as I see that, these two negatives become, so I have negative y equals 2 over x. Then what do I have to do? Do something to change this sign. So I'm going to multiply this side by -1 and this side by -1. So I get y equals, you only do this once, right? Not to both top and bottom. So you get -2 over x, which is this. So there's your algebraic proof. Okay, I'm almost out of time, but I want you to look at this. Why did Hofbauer put little stars and write, huh? It says -0.5 x to the 5th minus 3. Does that correspond to a parabola graph?
Not exactly.
Okay, anybody know what a to the 5th would look like? It would be like this with maybe some humps in the middle. Okay, but a negative would do what? Would go this way. But either way, one end should be down and one end should be up, yes? Okay, so this graph is totally wrong. What do you think about this? Just by looking at the powers.
It's not.
An x to the 5th and a constant.
It's not a function. No.
It is a function, but it's not have symmetry. Yes, because this is odd, this is even. If you graph it, it's going to do something like this, I think. It has no symmetry. Okay. This is the homework. I scribbled some stuff on the bottom of the page, but it's also correctly, I believe, typed on the gold sheet, okay? What's tomorrow's schedule?
Work day. You just hit record again, Miss Hofbauer.
I'd rather teach.
Miss Albright.
Oh, what?